Okay, so I've had this Fidelity radio record player to fix, and it's quite an oldish one. Incidentally, I've just left that turntable raised up a little minute, just so I can show some of the work that I've done inside. It's quite an old one. It's probably mid to late 50s, possibly. Very, very crudely made, as they were in those days, but still quite an interesting bit of kit to work on. Now, when I was given this to repair, the previous person that repaired it obviously replaced the motor and also the pickup as well, and cartridge. The motor originally was, I've got a little diagram here, was originally a center tapped motor, and in fact it's actually on the other side. This was the original arrangement down here. What there was, this was the motor winding with a center tap off it, which gave approximately 90 volts. I don't know if that's better, get it in sync. 90 volts for the two valve heaters, the rectifier and the pentode, which I've not shown. And that would have given approximately 35 and 45 volts across each of the two heaters. Hopefully, was that 35? 45. Yeah, that's approximately just under 80 volts. But that was the normal heater supply. Now, what actually happened was this motor had either burnt out. So the guy or whoever it was repaired it, obviously couldn't get the right motor. So they got a 110 volts, because they're extremely rare to get hold of now. Unfortunately, what the problem was, because he put a 110 volts transformer in, to prevent the transformer from overheating, what he'd actually done was he'd wired the motor, which is this coil here, in series with the two valve heater circuits, as opposed to how it should have been before. The net result of that was that these two sets of heaters were basically cooking. There was about 130 volts, 140 volts across the two windings, way more than what they're supposed to operate on. And also, the problem then, it's not really good practice, is that the heaters were in series with the motor, so you couldn't turn the motor off. Now, originally, I'm not sure if it had a cutout switch, but that would have had to be wired differently as well, because that would have affected this, which is effectively an auto transformer. So I don't think the original setup of these had a cutout switch for the motor when the record was in. The record player was in the off position. Instead, in the off position, it's mechanically done by removing the drive wheel into a neutral position. Anyway, that's by and by. So this is what the guy had done. But this is a 115 volts rating transformer. So we'll talk about that one first. So I tried a few different ways of doing it. Obviously, normal thing would be to get a transformer with split windings, primary windings like this, 120 volts. So I did that, and then that way, then that this was going to take care of the heater circuit. Okay, so but what I've done is there wasn't enough current in the primary to drive the motor as well. So anyway, we'll come back to that in a minute. So what I did was, I tried originally using a dropper resistor, but even with a heat shrink on it as well, I mean, yeah, it's not a very good heat sink. It should really be a finned heat shrink. That was just a lump of aluminium, which probably wasn't very effective. So consequently, still producing a lot of heat. Didn't really like that. So I thought, well, let's go simple. And I just put an incandescent bulb in series with it, and it's elegant, as the simplest solution you can have. A bit crude, but it does the job. But the only thing you've got to watch with this is that the rating the wattage isn't too high. Otherwise, the voltage drop across the bulb will be too small, and therefore the remaining power will be taken by the brunt of it will be taken by the motor. So you need a low wattage lamp, not too low so that the motor stalls, but something roughly to take approximately the same amount of power as the motor winding, and as I found, the optimum value was about 35 watts, which is what I've got in there. So what we'll do is we'll take the front cover off at the moment, still unscrewed at the moment. And the reason why I left the deck up a little bit was so that when I turn it on, you'll see the bulb at the back. And there we go, and it's wired just underneath. And in this arrangement, the bulb doesn't get too hot. It's right next to the air vent. It's clear from the floor and the spacing above and below the bulb. And it actually works quite nicely, and there's still enough torque on the motor to operate, if we can get this to work. Oops. There we go. And so there is actually plenty of torque in the motor still, so, and it does the job. So what we'll do is we'll have a little play in a minute, but we'll just talk through the rest of it. What I've also done as well is that whoever it was previously, the usual problem with these record players is that the crystal, I don't know if you can see it, there's enough light there to pick it up. The crystal pickup usually goes on them. So what most people do now is, because you can't get the crystal pickup, and also it's not good practice to replace them if you're going to use them on modern records, because they're not designed. The crystal pickups only has a vertical movement as opposed to lateral and vertical, which is required by more modern records. So this is fairly sort of bog standard moving coil dynamic pickup that's been fitted at some point. So I've wired this up, and what I've done is because the output from the moving coil mic is quite low, let's get some light on this, I've actually built a little Raya preamplifier to boost it and also give a little bit of equalization. Not that it makes much difference, because the frequency response of these things in terms of the loudspeaker is pretty poor. So this is actually a stereo one I built a few years ago just to save me knocking one up, and then that simply then feeds directly from the pickup, and then follows this green cable through here to the volume control on the front. Now on the input to the right, I've put a little preset control on there, and there's also a preset at the back which sets the DC mid-rail voltage. And so the circuit here is just above. I've traced it out. So what you want to do basically is this little preset here sets the DC offset for the signal coming out of the output pin. Because this is operating in single-ended mode, the operating level is found by this capacitor here. So this is an automatic. This automatically balances itself out to the. So you've got to adjust 470. This 470k preset here tell that with a very small signal input that the operating threshold is about mid rail, or the DC threshold is about mid rail with no signal present. And then I've put a little attenuator on the input. Because the gain of this was a little bit higher than what I wanted. A little bit crude again, but it works, it does the job. And then obviously this is adjusted then to give maximum output without clipping. So you just got to back this off until clipping isn't present. And that gives you roughly the right output to get a fairly reasonable output into the existing valve amplifier, which is then fed through into the existing volume control on the front. As you can see, very, very crude. The actual chassis on these were really, really horrible and very basic to throw together. There isn't even much space between the output transformer and that valve. I had to bend this chassis up. I think at some point in the past, somebody's actually fitted a replacement output transformer. Anyway, so I've also, part of the solution, to provide biasing for the valves, provide the heaters for the valves. What I've done is I've used this transformer with a split primary, wired the two windings in parallel to drop approximately 120 volts from the main supply. And then this tapping out there is fed in series with the two secondary windings, which is 12 plus 12 is 24. That effectively subtracts the output voltage from there, so we get approximately round about 90, well, sorry, so 120 minus 24 is going to be around about 96. It's slightly lower than that. It's around about 90 volts, so that gives me a nice 90 volt supply for the pentode heater and also the rectifier heater as well. So that's solved that problem and also taken the motor out of the circuit. So if I wanted to put an interrupter switch on the motor, I could do that, but I'm not going to bother because, like I said before, the turntable, we'll just have a quick look underneath there, is used to have an interrupter switch somewhere underneath there fitted on later models possibly. It can be done, but it's a bit fiddly, it's a bit of a job to do. So the only other thing really, so there's the transformer that I put in. I put a toroidal in. And also this is the regulator. This is used to sort of give me about 10 volts for the preamp. Now, I didn't have any decent voltage regulators in stock, so I used a couple of 78L05s. So it's approximately after single, I can only use a single-ended rectifier on here because this is one of the other problems with these things. Really dangerous if you wire these up the wrong way. Because we've got neutral at this point here, if I was to put a bridge into there, it would short circuit on the negative cycle, it would short circuit the secondary windage, which would then cause a massive current in the primary, which would then ramp up the heater voltages. So to avoid that, I've just used a single a half wave rectifier, which is adequate, into a reservoir capacitor there of about 100 mics. There's another reservoir of about 100 mics there as well. So what I've done is I've taken a couple of 78L05s. That's given me 5 volts, which I've then used as a reference for a second 78L05, which then effectively, with about 19 or 20 volts DC unregulated on the input, gives me then 5 plus 5 volts, which is about just over 10 volts on the DC output, which then is used to feed the op amp over on the sheet. So they're the modifications that I've done, and the last thing to do now is to test it. So what we'll do is I'll just pop the front cover back up, and we'll have a little play. But just before I do that, I'll just mention about the motor. The motor is running nice and cool because the motor's running at the moment. It's just the bulb that gets warm, but there's only about 35 watts, probably half of that, about 12, maybe 20 watts maximum being dissipated. So there's no problems with that bulb there at all. It just gets a little bit warm, but won't get too hot. So what we'll do is we'll just pop this record turntable down flat and we'll give it a go. So what I'll do is I'll use the auto changer on this as well, and just to demonstrate this, I've used a really nice, it's actually a Christmas song, but we're still in January, so why not? So we'll pop this on the auto changer, and because it's easier. I had to make a few adjustments as well. One thing is a slight problem is a little bit of pickup on there. I couldn't really, I didn't have time to really run a flying lead on there to the signal earth. But anyway, the deck is floating because I don't want that connected to 0 to neutral, because if the wiring should be reversed, then the whole deck will become live. So this is technically floating. So here we go. Let's give it a go anyway. So let's use the auto feature on this. Bit of luck on this. Let's test out the open.
Winter in the air, the nights are drawing in, the days have flown.
Sounds quite nice, doesn't it? There's plenty of volume there.
Tread softly while snow settles on the ground. The kids have gone now, so far away.
It's quite nice, that, actually. Whoops, I think the tracking weight needs adjusting. Oh, we'll stop that anyway.
Now, so far away.
See if it'll play. We'll stop that. So there we go. Probably needs a new stylus. I've not replaced the stylus, and probably what would help is to check the weight of the tracking weight of the stylus. But as far as I'm concerned now, I think that's a wrap. I'm gonna sort of like hand that one back, and so there we go. Hope you've enjoyed it, and please like and subscribe if you want to see any more. Bye bye.